looking at number 1 from Analyzing Functions assignment. And so I have an absolute value function. Notice that it is opening downwards, and the way we're able to come up with this diagonal as it goes to the bottom left and bottom right is it's being pulled both in the left direction as it goes down and in the right direction as it goes down, and that creates those diagonal portions of the absolute value function. So what is the domain? There's no limit how far it goes to the left, and there's no limit how far it goes to the right. So I'm going to identify that as the domain is from negative infinity to positive. It is important the negative infinity goes first. And again, we can't touch infinities, both positive and negative, so we have parentheses among both. The range, again, the smaller number has to go first, so there's no limit how far down this goes. It does go as high as this point, which is an x value of -4. And it's actually a point there at -4, so I include a bracket. Okay, when I look at this from left to right, so with intervals, we're talking about x values, and we're going to analyze it from left to right. If you're running uphill or you're increasing, and then in this portion of the graph, we're going downhill or decreasing. And at this particular point, it is neutral, neither increasing or decreasing. So identify the increasing. So I want to identify this portion. In terms of x values, it comes from negative infinity in terms of x values, and it continues to increase till it gets to an x value of 1. Now at 1, it's neither increasing or decreasing, and I illustrate that with a parenthesis on the outside. Likewise with decreasing, it starts after it leaves the x value of 1, after it leaves x value 1, which happens to be neutral, and it continues, now this is tricky, it continues to decrease as it moves to the right. So in terms of x values, not y values going down, in terms of x values, as it continues to go to the right, it is decreasing. Common error, students want to put a negative there. Okay, let's look at the end behavior. As I go to the far left of this graph, as I go to the far left, it is headed down. And as I go to the far right of this graph, it is also headed down. And so to show that, I'm going to put negative infinity. I'm going to identify the x-intercept, if they exist, y-intercepts, and then what would be the leading coefficient. Well, let's start with the leading coefficient. Because this absolute value function opens downward, it tells me that the leading coefficient has to be negative. And again, how do I know that? You would put this in words. Your reasoning is because you can see the absolute value is opening downwards. And now, is there an x-intercept? There is none. I can see it never crosses the x-axis. So I don't want to put 0 because 0 would actually demonstrate you think the x-intercept is 0. So I'm going to put the empty set. There is none. Or you could put no x-intercepts. I do see a y-intercept of -5. Continuing on to number 2. In number 2, we're going to start with identifying the domain and range of this linear line. So there's no limit how far it goes to the left or to the right. So I'm going to demonstrate that as negative infinity to positive. Again, there's no limit how far it goes down, and there's no limit how far it goes up. So negative infinity to positive. Now from left to right, this entire thing is going down or decreasing. The entire thing is going down from left to right. So in terms of x values, as it comes from the far left to the far right, it is constantly going down or decreasing. I meant to put that in the decreasing area. There is no increasing intervals. The end behavior, I start off with the basic structure. Whether you put the positive or negative first, it's really up to you. And now you look, as I go to the far left, what's happening? Well, on the far left, it's going up, and as I go to the far right, it's going down. Far left, it's moving up. Far right, it's moving down. Does this have an x-intercept or a y-intercept? The x-intercept is -1. The y-intercept is -4. The x-intercept is -1. The y-intercept is -4. Now, would this have a positive or negative leading coefficient, and how do you know? Well, I'm looking at the slope. Since the slope is going down, which means it would have to have a negative slope. or a negative leading coefficient, because from left to right it's going down. Remember, positive slope for linear lines is going to rise, and a negative slope, which would be your leading coefficient, is going to fall. Number 3 of analyzing linear functions, and then we are going to describe all the domain, the range, the intervals increasing, decreasing, and so on. So let's start with the domain. Okay, so I'm looking in terms of x values. Okay, so way over here, yes, I would hit the graph of the function. I would hit it, keep going. As I go from left to right, at some point I'm going to always hit the graph of the function. There are no, if you want to think, dead values here as I go. Everywhere, if I go on the x-axis and I go up or down, I'll hit some part of the function. For that reason, the domain is negative infinity to positive infinity. Okay, let's do the same for range. It's a little different answer. If I go down here, see how there's nothing? Nothing occurs until I get to a y value. Nothing occurs until I get to a y value of -2. And then it's dead space again. And then, okay, we're good. We got something. We got something. The whole way up I'd continue, because as this moves to the left, it's going up. So how do we write that? Well, 2 is a point. There is a point here at 2, so I'm going to include that. So the range has -2, and then it also has, it starts at a y value of 1, and there's no limit how high it goes. That's really tricky. Okay, let's look now at increasing, decreasing, and constant intervals. From left to right, I can see this is going down or decreasing from left to right. I can see this is constant and this is increasing. So in terms of x values, let's start with the increasing. So at an x value of 2, it starts this journey of increasing. But at 2, 2 is actually neutral. And it continues to increase as it moves to the right. Decreasing. It's decreasing way out here, continues to decrease, and it continues to decrease till it gets to an x value of -4. Comes from the far left and continues to decrease till it gets to an x value of -4. Again, at -4, it's neither increasing or decreasing or constant. Okay. Well, actually, it is constant down here, but not on this portion of the graph. Now, the constant. It is constant here. It is constant at -4, and it continues to be constant until it gets to a value of +2. But notice +2 has a circle. So from -4, we include that all the way to an x value of +2. Where is it positive and where is it negative? So the x values are, the y values are positive here, and the y values are negative down here. How would I write that? Okay, let's start with the positive. I'm going to do it up here so you're able to see it. So I'm doing identifying intervals where it's positive. Okay, this interval is positive. How do I write that? In terms of x values is positive from -infinity all the way to -4. But at -4, it's neither positive or negative because it's an open circle. It is positive from an x value of 2 all the way, continues to go to the right to +infinity. Now we can't touch infinity, but at an x value of 2, it's a closed dot. It is positive at that portion. For negative f of x, it is negative here. So at an x value of -4, it is negative. And it continues to be negative until we get to an x value of 2. 2 is an open circle, and for that reason, I put a parenthesis. Okay, the next ones, I'm going to write them up here so we can see them a little bit easier, would be to evaluate f of -8, f of -4, f of 2, f of 6. And I'm writing them up there so you can see. So what does this mean? So you're going to go to where x is -8, and you go up and down until you hit the graph. So that's input value. The output value is +8. I go to where x is -4. Okay, well, it looks like there's 2 places. Remember, we're looking for a closed dot. The output or y value is -2. Go to +2. Again, it looks like 2 places, but only the closed dot is what we consider as part of the solution set. Has a y value of 1. At +6, we have a y value of 3. 3 things left, end behavior, and then x and y intercepts. So I'm going to do it up here again so you can see. Negative infinity and positive infinity for the x's. Okay, so as I go to the far left, what's happening? Way over here, I can see that this is slightly going up still. I'm going to do this again. Let me go back here. As I go to negative infinity, which is way over to the left, the function is increasing. It's going up. And as I go to the far right, it is also increasing. What is the x-intercept? There is no x-intercepts. My only caution is don't put 0. Write no x-intercepts. Give me the empty set or a 0 with a line through it. But don't just put a 0. That would insinuate you think the x-intercept actually occurs at 0. Then are there any y-intercepts? There's one y-intercept. It's at -2, so you can write 0, -2. Finishing out this assignment with problem number 4. So we're going to start with domain and range. Okay. So if I come off here at the very far left and I go up or down from the x-axis, I'm continuously hitting some part of the graph. There are no empty spaces here in the graph. So all the way from negative infinity to positive, as I go along the x-axis, I will always touch some part of the graph if I go up or down. Now range is a little different. Coming through here, I see nothing. There's absolutely nothing until I get to a y value of -3. And then it's empty space again until I get a y value of 1. Then it's empty space again until I get to a y value of 3. And then as I continue to go up, I will always hit this part of the graph. Now at 3, notice it's an open circle, so I need to put a parenthesis around that. Next, I'm going to look for increasing, decreasing, and constant intervals. I can see this is constant, and from left to right as I read this, this is increasing. So I'm going to write on the graph. It's a little bit harder to see down below. So this constant here is going to go in terms of x values from negative infinity all the way to the left. It continues to be constant until it gets to an x value of -2. Now at -2 it has an open circle, so I put a parenthesis. This constant interval goes from -2 to +5, and since I have closed dots at both and it's constant, I get to put brackets around both. Increasing starts at a value of 5 and it continues to increase as it moves to the right. Again, open circle, and with increasing and decreasing we do put our parentheses. The next part is where is it positive and where is it negative? So I can see that actually starting from an x value of -2, I would always be positive, 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 the whole way would be. So positive f of x's occur from intervals of -2 all the way to positive infinity. And at -2, it's even positive, so I get to put a bracket. Where is f of x negative? Okay, so this is all negative down below. So it comes from an x value of negative infinity, and it continues to remain negative until it stops here at -2. Now at -2, it is open circle, so I leave it with a parenthesis. Then it asks us to identify f of -7, f of 5, f of -2, and f of 7. This means go to an x value of -7, and I get a y output value of 3. Go to an x value of 5, look for the closed dot, and I get an y output value of 1. Go to an x value of -2. Notice I see 2, but I'm looking for the closed circle. It means it's part of the solution set. I get a y value of 1. And finally, I go to an x value of 7, and I get a y value that also corresponds to 7. What is the end behavior? As I go to the far left-hand side, I can see it's constant at this value of 3. As I go to the far right-hand side, I can see it is moving upward. Are there any x-intercepts? There are no x-intercepts again. I could write the empty set, a line through it, or I could put no x-intercepts. We do have a y-intercept of 0, 1.